Welcome to the OCI Grails Quickcast, bite-sized portions of Grails productivity tips to help maximize developer productivity with the framework. Grails Quickcasts are brought to you by OCI, the home of the core Grails development team and your source for professional support, project work, and training around the Grails framework. Grails Quickcasts are distributed in partnership with dzone, who help build knowledge and relationships to maximize your success.
So today we're going to be looking at how to create a user interface for our Grails application using React. As you may know, Grails 3 introduced the concept of profiles, which allow us to generate Grails projects that are pre-configured for a specific kind of application, such as a REST API, a plugin, or a specific JavaScript framework. One of the core Grails profiles is the React profile. So in this quickcast, we're going to see how we can use this profile to get our Grails project up and running with React. Let's get started. So the first step is to make sure that we have Grails installed, which I do here with SDKman. Of course, we could also use the Grails application Forge to generate our project, but we'll create it manually for now. Our next step is to actually create the project, and at the same time, specify that we want to use the React profile. We can do that using the create app command, along with the profile command line option. Now I need to explain at this point that we're going to be using a specific version of the React profile. This is because this particular profile comes in two flavors. One is designed to support a typical Grails project using React along with GSP pages and other standard Grails view technology. So if you want to use React for only part of your application's UI, or you just want the simplicity of a single project structure, a single deployment, etc., this will be the approach for you. We'll look at the second option a little later on. To specify a profile's version, we use its artifact group, name, and version when we create our app on the command line. Notice that the profile includes some helpful instructions for getting started with the new project. Okay, let's take a look at it. So we have a pretty typical Grails project layout here, with a couple of differences. First, you'll notice that we have a package.json file. If you're familiar at all with Node.js, you'll already know what this means. This file is going to specify our dependencies for the React portion of our project. We'll look at it a little more later. There's a couple other new files here that we'll get to shortly, but in particular, let's take a look at our default index.jsp page. The first thing you should notice is that there's not much content here compared to the default Grails homepage that you usually get in Grails projects. Instead, we have an empty div here with an ID of root and an asset pipeline JavaScript tag loading a single file named bundle.js. We'll get back to this file in a minute. Let's take a look at what this app looks like when we run it. So here's our homepage. Now you should notice it looks very much like the default Grails homepage we're used to seeing, maybe with this extra React logo on the header. We have our navigation menus and our app metadata. However, this page is in fact a React app, and all the data was obtained via a REST call. Let's take a look at the code and see how we got this React UI in our Grails application. The profile expects React components to be located within the source main web app directory. This is a good location because by default, the source files here won't be available when the app is deployed, which is actually what we want in this case. If we open the index.js file, we can see that this is where the React app is actually being rendered. Notice that we're rendering to an element on the DOM with an ID of root, just like we saw in our GSP page. The React component that is being rendered is the app component. Let's take a look at that one. So here we have a pretty standard React layout component. It's using the React Bootstrap library, which makes it a little bit easier to use the Twitter Bootstrap library. Notice our API call here in the component did mount lifecycle method. This is where we make our API call to the application controller, retrieve our metadata, and store it in the component state. This state is then passed on to the app nav component, which renders our navigation menus. I'm not going to drill down any deeper here now because this is all standard React stuff. You can see that we have image references, inline CSS, as well as imported CSS files, etc. This should give you a pretty good picture of how much flexibility you have on the React side of things. You can pretty much do anything you can do in React. So how did this React component end up on the index.jsp page we looked at earlier? Let's take a look at one more config file. So I've opened up webpack.config.js. If you're not familiar with it, Webpack is a module bundler. Its job is to take our React components and other static assets, process them, and make them available on our page. In many front-end Node.js-based projects, Webpack is used to generate either a static JavaScript bundle for an HTTP server or Node Express server, or even serve the app itself using its dev server functionality. Here we've configured Webpack to load our React components from the source main web app directory, starting with index.js as our entry point. It then outputs the process files to Grails app assets/javascripts. This is the standard location for the Grails asset pipeline plugin. At this point, we can load our Webpack bundle on our GSP page, just like any other JavaScript file. I'm not going to go into the details of the Webpack config, as you can learn much more from the Webpack website and documentation. Instead, let's take a quick look at our build.gradle file so we can see how all these things are wired together into our build. So looking at our build.gradle file, you'll notice that we have a few new Gradle tasks. All of these tasks are leveraging the Gradle node plugin, which is installed and configured in the project by the React profile. The first task is bundle. This is the basic command that will call Webpack and render the JavaScript bundle to our asset pipeline. Notice that our boot, run, and asset compile tasks depend on the bundle task. This makes sure that the latest version of our Webpack bundle will be available when the app is started up, as well as packaged for deployment. The next Gradle task is called Webpack. It does basically the same thing as bundle, except that it runs Webpack in watch mode, so that changes in the file system are detected and the bundle is rebuilt as needed. You'll need to run this task in a separate command line process, as it never exits until you stop the task yourself. Let's go ahead and start it up. Okay, now Webpack has successfully regenerated our bundle. Of course, we haven't made any changes to our React code, so there will be no difference on the page. However, let's go back to app.js and make a change. When I save the file, you'll notice the Webpack has already regenerated the bundle with the new change. Going back to our browser and refresh the page, and there you have it. Webpack has regenerated our bundle with the latest changes in our React code. This will be a pretty typical development workflow when using this profile. Start up your Grails application using either the Gradle wrapper or the Grails command, and then run the Webpack task in a separate terminal. With both of these processes running simultaneously, you will be able to make changes to your React code and Grails code, and those changes will take effect at development time. Going back to our build.gradle file, you'll notice we have one more task to point out. This one is called Mocha test, and it runs any tests in our React app. The profile is set up to use the Mocha testing framework. There is a simple example test provided by the profile which you can check out yourself. By convention, React tests are included alongside the component being tested, and usually use the test.js or spec.js file extensions. The last piece of our build puzzle is going to be found back in our package.json file. You should notice that all the Gradle tasks we were just looking at are actually calling scripts from our package.json file. You can add your own scripts here in the scripts block, or modify existing ones if you need to. Because these scripts are here, you can actually run Webpack or your React tests without using Gradle or Grails at all. If you, or perhaps your front-end developer, has npm or yarn installed locally, they can run these scripts directly and have the exact same results. The Gradle integration with Node, of course, means that you don't have to have any additional tooling installed. But if you have the front-end tools and that's your workflow, then you can have it. Alright, so that's the first version of the React profile. Hopefully this will help you get started using this profile to create Grails applications using React. As mentioned earlier, there is a second flavor of the profile, and we are going to look at that one in the second part of this Quickcast series.
Thank you for watching this episode of the OCI Grails Quickcast. For more information on how OCI can help you with Grails or any of these other practice areas, visit ociweb.com or contact us at info@ociweb.com. Follow our Twitter accounts @ObjectComputing and @GrailsFramework. Also, read regular updates on the OCI Grails Team blog at grailsblog.ociweb.com.